In this video, I'd be talking about how threads interact with each other and communicate about certain events. So threads communicate about events by the following methods defined in object class, and the methods are wait, notify, notify all. A thread can execute these methods only within a synchronized context. So a thread for a thread to be able to execute these methods on an instance, it can only execute these methods within a synchronized method or synchronized block as shown here. So a thread should actually own the lock of an object before it can invoke wait, notify, or notify all on the object. So T1 so if T1 were to be a thread, T1 at this point gets object's lock and invokes wait on the object's lock. Now this is only valid because T1 has already obtained the object's lock. So for T1 to be able to invoke either one of these methods, wait, notify, or notify all on an object obj, it has to have the lock of obj. So once T1 gets obj's lock, it can call wait, notify, or notify all, which are defined in the object class. Now, because every object that you create is a type of object, or it implicitly inherits the methods defined in object class, you can invoke the following methods on that instance. Now, for example, if T1 doesn't get the lock of obj and tries to invoke wait, or any one of these three methods on obj, then it would result in a runtime exception. It's called illegal monitor state exception. It's an unchecked exception, so you don't need to have a catch explicitly defined. Now every object has a log pool and a wait pool, and as we already know, there is a runnable pool, right? And JVM scheduler would be picking up processes, picking up a process from, or picking up a thread from runnable pool. Now, when would a thread enter a log pool? Well, say if I had, okay, now as you could see, T2 and T17 are in object 1's log pool. That means there is a thread, say for example T1, which has obtained the lock of obj1 by invoking a synchronized method of obj1. So T1 has obtained the synchronized method of obj1 and has taken obj1's lock. Now T2 has invoked the same synchronized method of obj1, and so did T17. Now because T1 now has a lock, T2 and T17 would have to wait in obj1's lock pool. Similarly, when a thread invokes wait on obj1, then it would enter the wait pool of obj1. So say if T8 first gets a lock of obj1 and invokes wait method on obj1, it automatically gives up the lock and enter the wait pool of obj1. Now let's look into the wait method. A wait method could throw an exception. It's called an interrupted exception. Just like a sleep method could be interrupted, so is the case with the wait method. There is another variant for the wait method, which takes in time as an argument. It waits for 2 seconds, and then um, if it's not notified within 2 seconds, it would go back to runnable state, which I'm not really sure of. I think it actually goes back to the log pool, right? Which I'll be talking about shortly. So thread releases object's lock after executing wait on the object. Therefore, T1 releases, in this case, T1 releases when it executes this, or in this case here, T1 releases A's lock after executing wait on T. Right. So after releasing it, it would be it would be in the wait state, waiting to be notified. But T1 needs the lock back to continue execution. So let's take a look at. Let's try to get the whole picture. So when you do thread T1 is new thread of job, or my thread T2 is new my thread, then T1 and T2 are in new state. When you do T1 dot start and T2 dot start, they would be in runnable state, in the runnable pool actually, and the JVM scheduler would be picking up threads and moving them to running state. Now, if thread were to execute wait or wait a millisecond, then it would wait, and the only way you could go from wait to runnable state is in case of wait with milliseconds. After this timeout, you'd be going to runnable state, but not directly. You would be going to so the thread after the time expires would be moved to the lock pool, and it would only go back to runnable pool once it could get the lock. Right. So is the case with this. I would say it's not wait to runnable. It's mostly there's no such transition from wait to runnable. It should be wait to block to runnable. Right. So that's what happens here. After the timeout, a thread would actually move to a blocked state, waiting for the lock. And once the lock is available, it would go to runnable state. So is the case with notify and notify all. Once a thread executes, um, so so if a thread were to be waiting, and if another thread invokes notify or notify all, then the thread would be moved to a block state, because it would be waiting for the lock, and then once it gets a lock, it would be moved to runnable. So if my thread were to invoke wait on instance 1, and if another thread were to invoke notify or notify all on the same instance, which is instance 1, then my thread 1, which entered the wait lock or the wait pool of instance 1, would move to the the lock pool of instance 1 waiting for the lock. Right. So in that case, it would be in the block state, and then once it gets a lock, it would be moved to runnable state and given CPU slice. So when would a thread move from sleep to runnable state? Definitely after the timeout, and block to runnable state. Once it gets a lock, well, if it's blocked on a lock, it would only enter the runnable state once it gets a lock. If it was blocked on an IO, it would move to runnable state after the IO operation is complete. So notify all. So T1 enters, gets a log of OBJ1, gets a lock of obj1, and somewhere in the code notify all is invoked on obj1. Then what happens is it lets all the threads rush out of the waiting area and back to not the runnable but to to the log pool. So if obj1 had a log pool and had a wait pool with threads waiting, right, when this is invoked on obj, then all these threads would be moved to the lock, or the log pool. So that is, all these processes would be in blocked state waiting for the lock. So once the lock is available, one of these would be picked up and moved to running state. Notify is similar to notify all, except that it only uh, picks up or picks out a process from the wait pool and puts it to the log pool of an object. Let's consider an example. Right. In this example, the main thread is running the main method, and somewhere in the main method you create a thread B and you start it. So the run method is invoked on the same thread B, on the same object B. Now so at this point, okay, main acquires lock of B, prints this, and gives up B's lock and waits to be notified and to get the lock again to continue, right? So once it gives up the lock, then this thread would come in, and at this point it would be say for example, if main were right here, then B would be blocked here because main still has a lock of B, and this would be waiting for B's lock. But when main executes wait, then and it gives up the lock, and then which is available for B to pick up. So B picks up the lock, executes this piece of code here, and releases and notifies. Now at this point, when B gives up the lock, it would be put to the wait queue or the wait pool of instance B. So that is, so if this is my instance B, then main would be, and this is the wait pool, and then main would be right here after executing wait, right? And then at this point, main would be moved from the wait pool to the log pool. This is the log pool. So main would be moved from here to here at this point. So when so after calling notify, it releases one thread. The notify method releases one thread from wait pool of B, right, and place it on the log pool. So the main method would move to the log pool and would wait here until it acquires a lock, and then proceeds executing the remaining code. Let's take a quick look at what class implements what methods. As we all know by now, that wait, notify, notify all are defined in an object. Class thread contains implementations for start, join, which are non-static members or instance members, and yield and sleep, which are static members, and interface runnable has run method declared.